My name is Craig Strong, and this afternoon we'll be talking about our experiences bringing DevOps into a legacy mission-critical environment for the federal government with Kanban. So first, just a couple words about myself. I've been in software development for a long time. Worked both in the government and commercial space. Small business owner. We have offices in the New York City area and Washington, D.C. And in addition to sort of enterprise transformation coaching, I also enjoy getting my hands dirty and doing coaching and mentoring at the engineering practices level. So today, first I'll have to define what I mean by DevOps. It's one of those terms that everyone seems to have their own favorite way of defining it. Talk a little bit about the context of the project that we implemented these practices in. How we made the case for DevOps, right? That can be difficult for federal customers. And then the four aspects, the four practice areas that we focused on: build, test, deployment automation, and configuration as code. And Nyan did a great job of introducing many of these ideas. Thank you very much in his talk just now. And then to recap where we are, summarize, and talk about what we're going to do next. So DevOps, how do we define DevOps? Well, it's a clipped compound of development and operations, obviously. Really what it is, it represents sort of the integration of three disciplines or practice areas: development, operations, and QA. So it's concerning itself with the fault lines between them and the processes between them and making that more efficient. So in the large, you can talk about DevOps in the large, sort of the overall idea, or you can speak about very specific DevOps practices. So in the large, there are sort of multiple aspects or axes that you can talk about, including tools, processes, culture, and organization. So there are DevOps tools. Naya just mentioned one of them: Chef, Puppet, Ansible. These are some of them. And they're really about understanding processes, especially those processes that involve handoffs between teams, handoffs from development to operations, trying to turn that into just one seamless team and automating those processes. Now, in order to do that, obviously you need a culture that with a high emphasis on trust and collaboration, right? Now, once you've for example, DevOps Days a few years ago, an engineer from Etsy talked about how they deploy to production 5 times a day, sometimes more. So what's interesting about that level of automation is once you get to that kind of automation, there's really a whole another level of things that you can do. It really starts to affect the organization as a whole. Make a mistake, some bug in production, boom, we can fix that immediately. We can try out different things, feature toggles. There's a whole another set of things we can do when we achieved that level of automation. So this is sort of DevOps in the large. What I will be talking about today, the aspects that we focused on for our project and the federal government, is build automation, test automation, deployment automation, is configuration as code. So a little bit about the context, the project that we're working in. Unfortunately, I'm not allowed to name the federal agency we're working with, but it has to do with criminal justice, catching bad guys. And in the overall workflow of a violent crime, unfortunately, from collecting evidence to digitizing that as DNA, searching the DNA, matching a DNA profile against known profiles, hopefully leading to actual evidence, leading to an arrest and a conviction. We fit in around the lower left-hand corner there. So we're building and maintaining the software system that helps digitize the DNA and helps forensic laboratories around the country and really around the world as well match that DNA and help, again, catch bad guys. So the system has been in existence for a long time. So it's kind of like one of those redwood trees. You know, those big, huge trees, it gets cut down, and you can see the rings of the tree, and you see all the different times when there were droughts and things like that. So there are vestiges of source code in this source code base from 15 years ago. And every different sort of layer and different kinds of technology that came in. So imagine how difficult it is to implement new features in this kind of an environment, right? Or to implement a bug fix. It's a real challenge. So up until recently, until we got involved, it had been run, as many federal programs are run, using traditional waterfall life cycles, right? So this was sort of the history. This is what we started out with. So I wanted to speak briefly about the federal contracting environment, because it is pretty different from the commercial world. So typically, contracts are awarded on sort of 5-year basis and 1-year chunks. So the nice thing is, once you get an award, you've got a nice long time period to deal with. And what's interesting is when we first started working on the proposal for this, I was not as Kanban savvy as I am today. So I said, aha, we're going to do this as a Scrum project. Of course, naturally. And I was confident in saying that because there were some recent high-profile success stories, including one for the Sentinel project that's featured in Ken Schwaber's Scrum book. And in fact, the Agile has been enshrined now in the federal acquisition regulations, the official regulations. So it is perfectly acceptable to use Agile techniques on government projects. Doesn't mean it's done, that often yet, but it is a viable option. So what does this mean? Well, what's interesting here is there's a high degree of initial process flexibility, right? Once you get the award, the government says, look, you have to describe exactly what you're going to do and then do exactly what you describe. Document everything and then just do that. But you can do, pretty much, you have a lot of flexibility in what you set up. So that's the good part. The bad part is that it can be hard to change after you get that initial setup. Once we've discovered better ways of doing things, okay, you can do that, but you have to change all of your documents. So it ends up being kind of a friction, a drag. So what ends up happening is you have to really pick your battles. So the other thing is the way the federal government works. I put a negative here. It's sort of the way it is, neither negative nor positive. But the government typically outsources all of their projects. So each of these programs, like this criminal justice program, acts as almost an independent entity. So what that means is you really don't have access to the larger organization. You're not going to be changing the way the governance works at the federal agency or some of these other oversight groups. The focus needs to be on what features, how can we help the criminal justice community catch bad guys more effectively, right? That's the focus. So I wanted to briefly go over some of the challenges inherent to any legacy environment, because that's important this is sort of where we started from. Now, system criticality, well, if the system wasn't important, it wouldn't still be here, right? So generally, legacy projects exist because they're important. And certainly in our case, we're talking about a life-critical system. Something goes wrong, the wrong person can go to death row, right? It's pretty important. So that, of course, means probably, people are more conservative. There's more reporting. When I showed up, I was chagrined, to note that a huge cube farm, right? So it's not very conducive to working collaboratively. So the staff, of course, we had to have knowledgeable people who had been working on the program for a long time. Well, they've been working in a waterfall environment. They may not be perfectly willing to adjust to a Scrum way of doing things or an Agile way of doing things. Of course, high documentation, heavy documentation requirements, as you might expect, and 0 automated tests. So that's and that's if you want to procure something new. Of course, there's a lengthy procurement process. So a lot of challenges. But to make matters worse, it's, okay, we're going to solve everything agile, right? Well, not so fast. Unfortunately, most of the books that are out, that are available, at least certainly the Scrum-based Agile books, assume you're working in a greenfield environment. Right, there's relatively little guidance. There's a couple of exceptions, but there's relatively little guidance for legacy projects out there. So what about the practices? Well, you know, it's fine to say, well, we've got a time box now. In 2 to 4 weeks, you got to get everything done. Well, what if it takes longer than that just to get approval to go to production? You know, it's one thing to just say there's a time box, but it's not so easy for these legacy projects to do that, at least not immediately. The other thing is there's so many different things that need to get, it's sort of like triage. Where do we start? You know, what do we work on first? And finally, the tools. Right, we're talking about legacy systems. These may be old versions of operating system, old versions of tools. The new fancy, shiny DevOps tools may not even run on these platforms. They may not support these platforms. So the other thing is legacy projects often are data heavy, right? If you've got, especially in insurance or any mission critical project that's going on for a long time, you've accumulated a ton of data. And that data is very valuable. But things have been changing over the years. So a lot of it is what they call dirty data, data that needs to be validated, needs to be cleansed. And at least in my experience, I have not found too many great tools for doing that kind of testing. The sort of test automation that most people talk about is really in the code level, and there's not really much help in the data layer. So with all of these challenges, who in their right mind would sign up to do this? So I wanted to just ask everyone, can anyone think of a reason why you might still sign up for this?
Like pain?
Yes, you're a masochist. No? Bingo. Yep, so what's interesting is about 15 years ago, there was a book that came out about sort of impossible challenges and why people signed up for these crazy challenges. It's called Death March, one of my favorite books. So, but basically it boils down to a couple of factors. So one is the mission, right? We want to help catch bad guys. Like, who doesn't want to do that, right? So it could be a challenge, right? I want to do something that nobody's ever done before. Or I want to work with Joe. Yeah? So there's good reasons to sign up for that. People can and do sign up for these things. So what was the case for DevOps? How did we make the case? So that's where the systems approach to implementing Kanban comes in. And this is one of the slides directly from the Kanban training classes. So we'll get into a couple of these. Demand analysis. So we knew up front that there were some business features to help the criminal justice community do their job better. And there were some other features like improve performance, right? We called those infrastructure user stories. But it wasn't until we really got beneath the surface that we found there was a whole lot of other things going on. So for example, documentation. Well, it turns out that the labs have annual audits, and there's certain things that they need at certain times of the year. So the documentation requirements were bursty. There were certain times that those documents were required. So that was interesting. Tier 3, triage. So if a lab is down and the bad guy's getting away, drop everything. That is your #1 priority, right? So tier 3, those were always expedited. A new lab coming on, it doesn't happen too often, but every once in a while a new forensic lab comes online somewhere in the country. There's a certain date that lab is going to be up, and by God, the system better be ready to support it. So there's a lot of fixed date things in there. We went ahead and added technical chore, setting up a new server, that kind of thing. So we called those chores. So the point is there was a lot of other things, sort of dark matter, that wasn't immediately apparent until we did this demand analysis. All right, so we went ahead and color-coded the different work item types, different colors, plugged them into our Scrum tool, or using Microsoft TFS, And we were off. That's it. So we went ahead and got started. We started our sprints. Unfortunately, we fairly quickly ran into some issues. And I think our burn-up chart pretty much illustrates what might be a problem. So here you can see a sprint we were in the very beginning. What are the testers doing? Not a lot. They're waiting. So, but the last week of the sprint, nights, weekends, that was pretty typical for us. So clearly there was some problems. We had some issues to resolve here. So what we needed to do, so anyway, we captured our initial workflow, and here's kind of a typical Scrum-based board. You can see the release backlog here on the left-hand side, the input queue, all the ideas. And what's interesting here is you can see we have a fairly large batch size, right? 15, our WIP limit. So basically, that's reflective, that's typical for legacy environments, right? Because you're probably gonna need, from my experience, a longer sprint time, a longer time box than you would in a greenfield environment. So we captured our workflow like this, but obviously here's our problem. So you can see the bottleneck, lots of blocked issues, defects, and rejected fixes. So, and that's what shows up, right, with all the stuff being delivered at the very end. So this is where we kind of started with. So what we needed to do was do a real analysis. See what's the sources of dissatisfaction? What's really going wrong? And we noticed a couple of important things. First of all, developers were checking in code that broke the build. So check in something you want to fix, and things break. Fixing one issue seemed to create two more. That's a problem. And we said, well, you just got to write automated tests. And the developer said, well, hold on. If I write this automated test, it's going to extend the time to build this feature by 3 times. It's just too difficult to write these tests, right? The system isn't designed for these automated tests, so it's just too difficult to write them. Then when we finally got to get things done, the testers couldn't begin. Why? Because the code took so long to actually deploy into the test environment. Just getting the code in there was a lengthy process, many different steps, and very error prone. So once it's deployed, are we ready to test? No. Then we got to set up the tests, right? To set up the initial conditions, set up the data, all this stuff. That takes even more time. And of course, it takes a lot of time, and typically, after the testers are done, they're supposed to reset the environment for the next tester. Well, that often gets skipped, and of course, the inevitable result is many false positive defects due to configuration issues. The FTP server was down. The firewall was misconfigured. A patch went through. Lots of things causing defects that have to get triaged and looked at, but in fact, they're not real defects. So we had a number of issues that needed to be addressed. So we went back and redesigned our workflow to better reflect a reality of where we really were, not where we wanted to be. And we came up with this. So you can see here we've captured the deploy step. So we explicitly model that. We know that there's going to be a deployment. It takes time. And for test, there's a new column called setup, right? Because setup itself takes a long time, and you're not really testing. You're just setting up for test. So we wanted to model that explicitly. And you'll also see that in an attempt to improve quality, since we couldn't really do test automation, we added peer reviews, and that was certainly helpful. So we're doing manual peer reviews now. So, but you can see we still have a lot of quality issues. So first step is build automation. So build automation, how does it work? So for a typical project, like a greenfield project, here's how you might set up your build automation. You have your build automation server. You set up what's called a build chain. See how it's a chain of events happening? So you're going to create the code, maybe run your tests, and package things together, and then maybe publish into a binary repository. That what you're publishing is the installable code, your software that can then be installed in different test environments or even go all the way to production. And the great thing about this build chain is once you create it, you can actually clone that. So imagine that you've got you're working on a production, but you also, while you're maintaining the production release, you want to start working on the next release. Well, no problem. All you do is clone your build chain, and you're off and running. So you can have these different branches as streams of development all going on the same time, all being built on your build machine, no problem. Unfortunately, for a legacy environment, it's not quite that simple. So so a couple things. First of all, as I said before, we had to add other kinds of tests. So we call them SQL tests, any kind of test. So tests at the database level, right, to validate the data. We needed to add those because there were a lot of issues at that level. So we added those tests. That wasn't too big of a deal, but notice how we had to add drivers and patches. So just building the code itself and packaging that up, you couldn't run that. You actually needed to add a whole bunch of drivers and patches and other aspects into this legacy system before it was actually an installable thing, right? And that's just inherent to the legacy environment. So, and then if you wanted to develop, let's say, production and the new release at the same time, you needed to create a whole different build machine. Why? Because the way the legacy code works is it's assuming that it's the only thing running on the system. So there's all kinds of side effects and things. So you have to run these builds on completely separate environments. So it gets a lot more complicated. So that's build automation for our legacy system. So took a little work, but we got it done. So where did that leave us? So here's our updated workflow. And we can see that the build ready step has now been eliminated, right? Because every time somebody checks in code, like Nayan was saying, it automatically gets built, right? That build chain kicks in and builds that piece of software, and then we've got a releasable piece of code. This is great, right? So we've completely eliminated that step from our workflow. However, we still have significant quality problems, right? So we're not there yet. We have not yet reached, we need to keep improving. So let's go into test automation. So with a typical test automation, right, here's sort of a typical architecture for a system. 3-tier architecture, right? We've got your user interface in the top, your business logic in the middle, right, and your database at the bottom, right? Pretty typical, right? So how would those tests work? Well, most of your tests will focus on the middle tier, right? That's where you really want to test, right? So you've got these nice little tests. You might write more than 1,000 of them, and you might execute in 30 seconds or less. That's awesome. Minimal setup required. There's no real side effects. Running one test isn't going to affect another one. You can just run them all quickly. Not so much for a legacy system. So what do we have for a legacy system? Well, for us, almost all of the business logic was in the database. And what little business logic remained was typically way up in the GUI, right? Embedded in the GUI logic. So it's sort of exactly where you don't want it to be. But that's just the way it was written. So what it means is if you really want to test that code, right? We've got 2 million lines of code. We want to make sure we've got to support the mission. We can't rewrite it. We can't throw it away, right? This is in production, so we've got to test that stuff. So unfortunately, what that means is you're not really writing unit tests anymore. These are a different kind of tests, and they're going to run slower. They're going to go through every layer of the architecture. They're a lot more difficult to build. So how did we do it? Well, we did that by inserting those 2 steps into our build chain. So now you can see our DevOps build chain, right? This is the build chain. And we've inserted 2 more steps. We're preparing the test database with all the test data that's needed, and then executing those tests, right? And the problem is both of those things are very lengthy, very time-consuming, and your build chain needs to be fast. So how do you fix that? Well, first of all, you split those tests into multiple batches and you run them in parallel on different machines, right? So if you've got 1,000 tests, you might run 300 on 3 different machines. So that's one way. That makes running tests, executing a test faster. But what about preparing the test database, right? That could be really time consuming. So we don't do it. In fact, we create a database image up front. We store that in our binary database, and then every single time we start a new build, we simply take that copy of the gold image of all the test data, everything set up perfectly, and simply restore that on the build machine so we can then run the tests using a known good starting state. So that was how we managed to get automated builds, automated tests. We're up to 1,000 now. High quality automated tests in a legacy system. Not easy, but we got it done. So let's look at our updated workflow. What has that done for us? Well, we can see quality is slowly starting to improve, right? We've got fewer blocked issues, fewer defects. That's great, but it still takes too long before we can test, right? Still there's that lengthy process to deploy to the test environment, and testers still have to do a lot of manual setup, right? So we're still not where we need to be. So what do we need to do next? Let's look at deployment automation. So how does deployment automation look like in a typical situation? Well, typically, you would add yet another step to your pipeline, right? So we were up to the binary repository before, right? Every time a developer checks in code, might be some C# code here, our build server is going to build it, create a package, that cardboard box there, put that into your binary repository, and then you might have an automated deployment service, like Octopus in this case, which a tester can then simply press a button and say, I want to deploy this in this environment. Deploy it into their test environment, and they're off and running. That is how it should work. Not so much for a legacy environment. So for us, there were a lot of extra steps. So what did we have to do? Well, we had to understand those steps, we had to capture them, and then script them out. So you could see that in order to make this deployment, every time we're deploying, we're first preparing the servers, that they can take this, deleting the old version. Then we're doing all the steps for deployment, and then finally the post-deployment steps. Those are the test configuration steps, adding the test users, configuring the settings, and cleaning anything up from the previous session so we don't get these false positives, right? So these are all the extra steps we had to add to the deployment process so we could automate our deployment to test for our legacy system. So we got this done. What did that do to our workflow? Let's take a look. So we can see that the test setup step has been completely eliminated, gone. Every time you do deployment, poof, the test is ready to go. It can be run immediately. That's great. And the deployment step, while it's still there, it's been significantly streamlined. Now deployment is basically press a button, I want this to go there, right? It's no longer this lengthy manual process. That's good too. So we're still capturing it because it is a manual, it's a pull. The testers decide when they're ready to deploy a new release to a test environment. But we are still getting some false positive defects, right? We still have situations where the application's okay, but something in the environment went wrong. So there's one more step we need to look at, and that is configuration as code. So what do I mean by configuration as code? So let's go back and revisit what deployment really means. So deployments really have two pieces, right? So one piece we were talking about before is our application, what we're building, right? So that, every time we make a new change, we probably want to deploy a new version and test that, right? So that's getting deployed, new versions of that are getting deployed to test all the time, right? That's the actual thing that the users at the forensic labs are actually using. But there's another step. That's the platform itself. So in order to deploy this stuff, you have to have a system capable of running it. So in this case, this is a Windows environment, and there were a lot of steps to get something ready to run the system. So database, firewall configurations, all kinds of stuff. So we looked at that and said, oh my goodness, we have got to look at this and see exactly what's needed to configure an environment so that it can be ready for us to deploy. So we know what a configuration is, a good configuration. So, so for a typical environment, what you would do is capture all those configurations in code, and that's what I mean by configuration as code. So you're capturing all those steps of setting up your database and your firewall settings and everything, all in source code, using a tool like Chef, Puppet, Ansible, whatever it is. And then you configure your environments. You might have a database server, compute server, web server. That's a pretty typical setup. Not so much for our legacy environment. So for us, we actually found that we had 24 different things that needed to get configured before we could deploy anything. So here's the list, lots and lots and lots of stuff. So how did we do this? It's a lot of configuration. So, well, step one is just understanding what you need. So step one, yep, typical federal government, we documented it. So we got a 300-page document, 100% manual, and that's how we configured it. So that was step one. Then we said, well, can we automate that a little bit? So we did, we partially automated it, pieces here and there, made some scripts. And we said, you know, we've got to do better than this. We need something that can really terminate these issues. How can we fix this and make things better? So I like to call it the configurator. So what is the configurator? So the configurator is a script that I wrote, which basically does that job. So it has a recipe, it understands all the different 24 things that have to get configured and where they need to go. It's going to take the third-party tools and all the Windows patches and everything else and install a number of, and here we can see one of our test environment nodes. Each of our test environments has, I want to say 40 nodes in it, and there are 5 environments. So we're talking about 200 individual machines that all would have to get deployed. And actually, that's a small number. There are many agencies that have thousands of machines. The difference is ours, every single one of these was configured differently. So, so there's a lot of, so that's how we got configuration to configuration as code working. So what's interesting about this is used not only for the initial configuration, but also to validate the configurations. So what does that do to our workflow? Well, finally, we're starting to see a greatly reduced incidence of false positive defects. That's great. And just for configuring a new test, or when we need a new test environment, that process used to take weeks. It now takes hours. And validating a test environment, making sure that FTP is still going and all the different steps are set up properly is down to minutes. So that's something you could even do, run every night, make sure your test environments are good. So now our testers have an automated process to deploy, and they know they can have confidence that the test environment is set up properly for their tests. So what are the key takeaways? What are some DevOps practices that might benefit your project? Well, we mentioned 4. Build, test, deploy, and deployment automation and configuration as code. For legacy, yep, it's very, very difficult, but for these mission-critical projects, for these important projects, it can be worth the investment. And Kanban system and static is a great guide to help you along your journey. So what are the next steps? Well, metrics. Where are the metrics? So I'm certainly going to go back and look at, I think cycle time will be a big one. And we should see, certainly we're anecdotally seeing greatly reduced cycle times. We need to go back and actually show those nice charts and graphs like you've seen in all the other presentations. So we'll certainly do that. The other thing is we need to deepen our Kanban implementation. The nice thing is that there is a, what David likes to call punctuation point coming up. So this contract is ending, and we were awarded the next contract, the next phase, which is great. And I made sure to put the word Kanban explicitly in the proposal this time, so we can use it without raising eyebrows. It's awesome. So we'll certainly do that. We need to establish a real WIP. All of this was done with basically no WIP limits, right? You can see that there. But of course, we can get lots more benefits from doing that. And really, it's time to get rid of the tyranny of the time box. We really need to move to service level, especially since we have so many different work item types and classes of service, right? Of course, our tools are getting better as well. So with that, that finishes my presentation. I'd like to leave you with one of my mantras. And with that, I'll take any questions.
Any questions?
What was the motivation to get the programmers to actually buy into all the automation, especially the testing automation? How did you make that happen?
is a really, really good question. So actually, this is a problem I've been struggling with to sort of motivate people, how to get people to change. It's something that many of us have been struggling for our whole careers. What I found to be, so there's two things. One is people, programmers, developers, people, technical people, they love to have new things, shiny things on their resume. So if you can sort of work with them and say, oh, we're going to work on this cool DevOps stuff, you sort of get them excited and do that. So that's certainly one way. Another thing is for the automated tests, that was a tough one because automating the tests, there was this tremendous amount of setup that we had to create. Now creating tests is easy. But to create that test framework was a lot of work. And what we ended up doing was we talked to our customer, and they actually issued a brand new task order. And we actually got that added to our contract as a new task order to build the test framework to do that. And they found of course, we're talking about a program that's been in existence for 20 years and will probably continue forever. So in light of that kind of time frame, making a big investment of 6 months to a year in a test framework makes sense. So that was what we ended up doing.
Another question. In your slides, you talked about that big document you had to have. So were you able to do away with documentation, or did you automate a way to create that huge document?
A great question about documentation. So I actually have a whole other presentation about documentation because it's been a major issue. It will always be a major issue. There's no silver bullet, but basically a lot of different things. First of all was just changing the makeup of the team, making sure there's at least one or two in the beginning, actually for the surge support to get things under control, two very senior technical writers on the team. You don't often see technical writers on a Scrum team, but we had them. So that was one of the first things. There's a tool called Perfected. It was an awesome tool. So that really helped us. We ran that because the government is a very, they're real sticklers on punctuation, everything being perfect. So that was an automated tool we could run on our Microsoft Word documents. In some cases, we did generate things. We had some automatically generated reports that we put into take the place of at least pieces of some documents. And certainly, for example, that 300-page, that specific document, I just worked on the latest version of that myself since I wrote the configurator. It's now 130 pages. So still a monster. A lot of that is screenshots. But a lot of the steps were, 30 manual steps, and now it says run script X. So.
Question over here.
Hi, so we have a painfully legacy project we're developing a new one right now, and it's in healthcare, so it's also heavily regulated. And you talked about these the 4 pillars, and those are all lovely things that we would like to do. How long did it take you from start to, I guess you're still working on it, but to your current state?
Yep, that's an excellent question. How long does it take to implement all this? Well, it really depends on the investment levels. One of the other talks I give is about, do we do a big bang, a lot of investment up front, or do we, keep the investment level the same? And one of the arguments that I like to make is you can do this without changing, without spending a ton of money and without changing it. It just takes longer. So this actually took us 3 years because we did it at the same time we're doing all of this stuff, we released, I want to say 6 new releases to the criminal justice community. So there was a steady stream of new features to help catch bad guys, right? Because that's the mission, right? That's what we need to do. So this stuff was all on, your sort of back burner. And I want to say back burner, but it was less than 30% of the overall effort. And in fact, that's part of the negotiation we did. We would actually come to the Scrum planning meetings and would say, okay, what percentage of our velocity are we going to spend on these improvements? And we negotiated that up front. So in the first year, we actually negotiated 50%, and then it gradually went down after that. So that I guesstimate if we had really invested more heavily, we probably could have all done in a year. I'm not sure any less than that, just because the legacy environment is so challenging. Yeah.
Oh, hi. She said make it a good one. So first, just a comment. I think I'm sort of in shock and awe that you pulled that off, so that's amazing. So we also, I think, like person over there, are interested in automating a lot of the documentation, the compliance, validation, things like this. We are also in a regulated environment in big pharma. And so I want to talk with you or anybody else who's interested in this space later, but I guess maybe a question about some of the tools. So if you look around sort of the Java world or even the .NET world, it feels like there's just no shortage of different tools that you can try to stitch together. Is there, I mean, maybe my question is, how long did it take you to come up with a tool set and get something working? It's not something that you can just sort of buy off the shelf, right?
Right. Oh yeah, no, there was, the build or buy question, there's a lot of different reasons to go one way or the other for tools. It's interesting, in some ways, some of the tools we sort of backed into. So for example, TeamCity, you can actually use that for free for a long time. So we actually had, there was another task order to do a prototype the government wanted to do, and we went ahead and used TeamCity on that. And after 3 months, everything was working so well, we said, hey, look, this is working great. Can we use this on our big project? And they said, oh, okay, yeah, go ahead. So there's different ways of doing that. In other cases, so actually that was, we used that technique more than once. We sort of, bringing in a free version and then proving it, and then getting the investment after that. For some reason, I guess different places are different, but the government was never, they never really had that much of a problem spending money on tools as long as it was justified. As long as they could see the value and you could articulate that, they were okay with it. So.
That's it. Oh.
So was the dev? Sorry, that was a little hot there. So the DevOps, was that pitched as just a minor improvement in the overall effort that you were performing, or was it something that was just a intangible kind of concept, and they said, okay, if you can do that, that'd be great, but not necessary? So how did you kind of sell that to your government client?
That's a great question. How do you sell this to the government client? So I don't think we've ever used the word DevOps. So it was always, what problem is the team having, right? Oh, we have a quality issue. Everybody knew that. There was defects, right? So there was, I think up front, they understood the need for test automation. And then it was up to us. That's one interesting thing with the government, is they really say, look, we're not here to tell you how to do your job. We want you to get these objectives done, and then you tell us in your professional opinion what you need. And that's exactly what we did. Well, we need to do this to make test automation work. So it was very much, and then the false positives. So I never used the word configurator or DevOps or any of that kind of stuff. It was basically, well, we needed some way to configure things, and we can either, so we did our sprint planning, right? We said, well, we can either, here's a user story, we'll take, we're estimating this will take 6 weeks to do manually, or I could write this script, and I estimate it'll take me 2 weeks, and then the thing will be done in 3 weeks. So, of course, it always took a little bit longer than that, but in the end, that did work. It's really by focusing on the problems, articulating the problems, and getting agreement. Like, okay, we need to solve this problem, and that's really what DevOps is all about: is these problems and solving them. So. All right, I guess that's it. Thanks very much.